So we shall learn about how to interface a stepper motor into the microcontroller and to rotate that in clockwise as well as in anti-clockwise direction. Okay, so before going into the program, first we shall know what is a stepper motor. So a stepper motor is an electromechanical device which generates discrete displacement. So discrete displacement in response to DC electric signal. So stepper motor is an electromechanical device, so which usually converts the electrical energy into mechanical energy, and also it usually generates a discrete displacement motion in response. So here the displacement or the rotation will not be continuous, so it is a discrete displacement or motion in response to the DC electric signals which is applied to it. It differs from the normal DC motor in its operation that the DC motor produces continuous rotation on applying DC voltage, but whereas a stepper motor produces a discrete rotation in response to the DC voltage applied to it. Stepper motors are widely used in industrial embedded applications, consumer electronic products, and also in various robotics control systems. The stepper motor can be interfaced to the microcontroller board by connecting it into the Power Mate PM1. So the Power Mate PM1 is the interface which is available in the LPC2148 microcontroller, where the the peripheral called as the stepper motor is being connected to it. The rotating direction of the stepper motor can be changed through the software, which means that so from your program, through your program, the motor head or the shaft of the motor will be rotated in clockwise direction as well as in anti-clockwise direction. It based on the rotation is based on the program you write. Then port lines used for stepper motor are P0 12th pin to P0 port 0 15th pin. So here 4 pins are associated to the stepper motor. So starting from port 0 12th pin and port 0 15th pins, which are port 0 12th pin, port 0 13th pin, port 0 14th pin, and the fourth one is the port 0 15th pin. So there are 4 pins which is associated to the DC motor, stepper motor. Actually, there are 5 pins. The 4 pins are associated to all the 4 pins are associated to port 0 12th pin to port 0 15th pin. Another pin is connected to ground. So there are 5 pins actually. So, but we usually talk the main 4 pins are port 0 12th pin, port 0 13th pin, port 0 14th pin, and the last one is port 0 15th pin. All the 4 pins are comes under port 0 of the microcontroller. Then so this is stepper motor operation. So you can see, so as we have discussed in module 3, so there are 4 coils which are connected to the stepper motor. So all these are works on the magnetic field which is generated applied by applying the DC voltage. So here you can see, so this is coil A, so this is coil B, and this is coil C, and this is coil D. So there are 4 coils that are associated like this. So here is we have a magnetic field that is generated when applied when DC voltage is applied. Okay, so these are the 4 coils. Here each and every coils, all these 4 coils are associated to 4 pins. Here coil A is associated to port 0 12th pin, coil B is associated to port 0 13th pin, coil C is associated to port 0 14th pin, and coil D is associated to port 0 15th pin. So if we activate the coils, so if we activate the coils one by one after other, uh, like first when we activate the coil A, after when we activate coil B, so afterwards we can activate coil C. Then after if we activate coil D, so then the rotation will be in clockwise direction. If you activate the coils or if you activate the port pins reverse order, then the motor head or the shaft direction will be in reverse order, nothing but anti-clockwise direction. Okay, so as I told, port 012 pin is associated to coil A. So the first it will be activated, and at a time you can activate only one pin. Only one pin can be activated at a time. You cannot activate all the pins. If you activate all the pins at a time, then there are no operation. The motor head will not turn either in clockwise or in anti-clockwise direction. Then Yeah. Then if we activate 4012 pin, afterwards if we activate 4013 pin, afterwards if we activate 4014 pin, after that if we activate 4015 pin, so then the motor head will rotate in anti-clockwise direction. If we activate in reverse order, then the motor head will rotate in reverse order, the reverse direction, that is nothing but anti-clockwise direction. So this is how the stepper motor works, and at a time you can activate only a single pin. Okay, which means that at a time you can activate only one coil. So the various applications of stepper motor are 3D printing equipment, robotics. It is used in robotics. Then it is used in textile machines. Then it is used in printing process. Then it is used in gaming machines. Then it can be used in medical imaging machinery. Then small robotics. Then CNC milling machines, welding equipment. So these are the various applications where these stepper motors are being used. So if the stepper motors are being used, then obviously it will be driven by the microcontroller. So in all these applications, we have a microcontroller as well as the peripheral called as stepper motor. So this is the stepper motor. So here you can see the stepper motor. So this is the shaft, or it can also be called as the head of the stepper motor. And these are the 4 pins which I told. So all these 4 pins are connected to the four corresponding to the 4 coils. So here the first pin is connected to coil A, second pin to coil B, third pin to coil C, and the fourth pin to coil D. So all these are associated with 4 pins. So port 012 pin is connected to coil E, port 013 pin is connected to coil B, port 014 pin is connected to coil C, and port 015 pin is connected to coil D. So if you connect this interface to the microcontroller, then obviously the stepper motor will rotate in clockwise or in anti-clockwise direction. So this is the microcontroller which we are using in our lab. So this is LPC2148 microcontroller. So here you can see this stepper motor interface. Okay, so here there are 5 pins. 4 pins are connected to the stepper motor. So the 4 pins are, which I have already discussed, the 4 pins are port 012 pin, 13 pin, 14 pin, and 15 pin. All 4 pins are comes under port 0 of a microcontroller. So this is where you should connect the this is where you should connect the stepper motor. So there is a notch at the connector. So that notch should match with the notch which is there in the interface of the microcontroller. So you should connect this. So you should connect this stepper motor to this interface. Then the stepper motor will be driven by the IC which is associated, which is connected to it. Okay, so when we power on the stepper motor, obviously the stepper motor will rotate the shaft in clockwise direction as well as in the anti-clockwise direction. Okay, so then we shall see the resistor configuration of all the 4 pins which we are using in our stepper motor. So obviously we will be using this resistor configuration in our program also. So as I told, there are 4 pins which is used in stepper motor. All these 4 pins are associated with the 4 coils which are there in the stepper motor. So here coil A is associated with port 012 pin. So coil B is associated to port 013 pin, and coil C is associated to port 014 pin, as well as the coil D is associated to port 015 pin. Let's see how to activate a single pin by considering the resistor configuration. So the first one is a resistor configuration to activate all the 4 pins. So why we need to activate all the 4 pins? To set the direction, to set the output direction, we need to activate all the 4 pins. So let's see how to activate all the 4 pins. So as I told, so there are 32 pins. So you can see that ranges from 0 to 31. So here, if you want to activate all the 4 pins, the 12 pin, in the 12th pin you should write 1, then 13th pin will be written as 1, in the 14th pin should be written as 1, and also the 15th pin should be written as 1. All other pins should be 0. Okay, so the triple one, so the four ones are in binary representation. Obviously the data which you send to the microcontroller, that should be in hexadecimal format. So if you convert this binary number to the hexadecimal number, so then 4 ones in binary will be called as F in hexadecimal. Okay, 4 ones is equal to 16. 16 is represented as F in hexadecimal, and all other we have zeros. So this register configuration is the resistor configuration to activate all the 4 pins is 40F000. 40F000. This is the resistor configuration to activate all the 4 pins. So when we usually activate all the 4 pins means, so at the time of setting the directions, at the time of setting the direction as the output direction, we usually activate all the 4 pins. But in the operation, we cannot activate all the 4 pins. While doing the operation, we cannot activate all the 4 pins. At a time, we can activate a single pin. Then only the motor will get rotated. Otherwise, if you activate one or more pins at a time, then obviously the motor head will not rotate. So next, let's see the resistor configuration to activate a single pin. So that is a port 012 pin under a coil A. So let's see how to activate the coil A in this stepper motor. So coil A is, as I told, the coil A is associated to port 012 pin. So these are the port 0. In port 0, as I told, there are 32 pins, ranges from 0 to 31. So 12 pin, under 12 pin, you should write 1. Then under all other pins, you should write 0. So if you convert this binary data into hexadecimal, that is 0001 is a binary representation. If you convert that binary representation to an hexadecimal representation, then it will be called as 1. So the final register configuration after converting to hexadecimal is 40100. 40100 is the register configuration to activate the port 012 pin. So likewise, so let's see how to activate the port line port 013th pin. Okay, under 13 you need to write 1 here. So as you can see here, under 13 you need to write 1. Under all other pins we should write 0. So if you convert this binary number to hexadecimal, so the binary number is 0010. 0010 is usually 0010 is 2 in hexadecimal. So the hexadecimal representation of a port 013th pin is 40200. If you want to activate the coil B, is the coil B, as we all know, the coil B is associated to 13th pin, then obviously you should set the resistor configuration as a 40200. Next, let's see how to configure the coil C. So the coil C is associated to port 014 pin. So here in this resistor configuration, you can see that under 14 we have written 1, under all other pins I have written zeros, which means that if you want to convert the binary representation to hexadecimal representation, then the binary representation number is 0100. 0100 is equal to 4 in hexadecimal. So the final resistor configuration to activate coil C or port 014th pin is 40400. After that, resistor configuration to activate a single pin, so that is nothing but the port 015th pin. So here under 15th pin you should write 1, and under all the pins you should write 0. So if you convert that binary representation to hexadecimal representation, so here the binary representation is 1000. So if you convert that to hexadecimal, then it is represented as 8 in hexadecimal. So the final hexadecimal configuration, final register configuration to activate the port 015 pin is 408000. So these are the register configurations which are associated with, these are the register configurations to activate all the pins. So when we usually need to activate all the pins, Andre, so we need to activate all the 4 pins when we set the direction to the pins. When we set the direction here, the direction is output direction. Okay, which means that whatever the whatever the thing which is processed at the ARM processor, so that will be driven in the stepper motor, which means that the output will be driven in the stepper motor. So that's why we need to set the pins as output pins, output directions. Okay, uh, the next is all about the program. So I will explain this program in the Keel IDE. So let's see how to execute the program on Keel IDE. I will close this, minimize this. So in the desktop or in your system, you can find Keel Microvision 4. Okay, so in your desktop you should find the Keel Microvision 4. So before opening, so create one working folder. So create one folder under your name where you need to save all your program, all your executable program on this folder. So you create one folder on the desktop. Okay, after creating one folder, so here I've created a folder called PROG. So in this folder I will be saving all the projects and all the files which I create in the Keel Microvision 4. Then double click on the skill microvision 4. It will take some time to open. Okay, so after opening the Kill Microvision 4, if there are any projects on the screen, then go to project and you need to select close project. If there are no projects, then well and good. So no need to close the project again. Now we need to create a project before creating the file or before executing the file. The first step is to create a project. Okay, go to project, click on new Microvision project. Then go to the root folder which you have created at the desktop. So here I have created a folder called PROG. So I will select this and I will name the project as Stepper. Okay, no need to give any extensions while giving the project name. So okay, the project name should not be any with should not be stored with any extension. Click on save. So after that, select device for target 1 window will come. So in the search bar, you need to type LPC2148. So LPC2148 is the microcontroller which we are using in our lab. So when you type the LPC2148 in the search bar, so at the below screen, you can see the interface of LPC2148. Select that interface, then click on OK. When you click on OK, so it will ask copy startup.s to project folder and add files to project. Here you need to click on S. So once again, I'm telling when you are executing part B programs, here you need to click S. When you are executing part A programs, then we need to click on No, which means that to execute all the part B programs, we need a startup.s file. But whereas to execute the part A program, we don't need startup.s. So why we need this startup.s file to execute all the part B programs, which means that for the main reason is it consists of all the header files. It consists of all the header files where the startup.s is called as the library file. So the all the predefined functions and all the ARM instructions are stored and defined in this startup.s. Which so for that's the reason to execute all the part B programs we need startup.s file. So you need to click on S. Again, click on S. So after that project has been created, now we need to create a file. Go to file and select new. Okay, then go to file, click on save as. Okay, so we need to save the file. So here I will save the file as stepper motor dot c. Here the file is here the file which we are saving is in dot c extension, which means that in this file we are writing C program. So that's why the file should be saved with dot c extension. So give dot c extension while creating the project. No need to give any extension, but while creating the file you need to give the extension as dot c because we are writing C program into this file. That's the reason. Click on save. Okay, so we have created the file. So the next thing is we need to link the file to our project. So let's see how to link the file to our project. So here in the project window, so which is available in the left hand side, so there is an option called the target one. So here we have a plus symbol. Click on that plus symbol. Then so source group one. So under source group one, we already have a startup.h, which is a library file. So we need to link another file. So that is steppermotors.c. So select source group one, right click. So you need to click on add existing files to group source group one, third option. So just click on that and So here we have already created a C file, stepper motor. Select the stepper motor and click on add. Okay, so close this. So now you can see under source group one there are two files. One is startup.s, which is a library file. Another one is the stepper motor.c, where we usually write the program. So type the program here, then save the program. Okay, so here in this program, as you people know, first I'm including the what header file. So the header file is LPC214X. LPC214X dot H. X stands for either it can be a 2 or it can be 4 or it can be 8. In our lab, we are using LPC2148. So in general, I will be giving the header file as LPC214X dot H. H stands for header file. So we are including this header file. So why we need to include this header files? The reason is, so we are using some predefined ARM instruction from we are using some predefined ARM instructions. So all those predefined ARM instructions are defined in this header file, and this header file is defined in startup.s library file. Okay, so next I have taken delay function. So first, why delay function is needed and tell us. So first, this stepper motor will rotate in clockwise or in anti-clockwise direction. The direction can be anything, but after rotating some amount of time, the motor should stop, or the shaft should stop. So then it should start rotate in the reverse order or in the reverse direction, which means that we need some delay to see the output, whether the motor is rotating in clockwise direction or in anti-clockwise direction. So for that's the reason I'm writing the delay function here. The delay function is the written type of the delay function is void, and I'm passing one argument or a parameter that is called as unsigned int x. Here at the function call, some integer value will be passed. That value will be in terms of microseconds. Okay, so then within the delay function, I am defining two variables I and j, where I and j are the loop control variables. I'm using two loops here, two for loops. The first for loop is I is equal to 0 and I is initialized to 0, and I will execute, or it will iterate till x completes. So if we pass x is equal to 100 at the function call, then obviously the first for loop will be iterated till it reaches 100. So after it reaches 100, so then the condition will become false. It will come out of the for loop, out of the main for loop. So inner for loop is j loop. So here j is initialized to 0 and j is less than 1275. So here 1275 is a constant number. So by trial and error, I have taken this number. So it usually depends on the hardware which we are microcontroller hardware which we are integrating it. So this is a constant number to get some amount of delay in terms of microsecond. So this j loop should be executed infinite times. J should be not infinite times. The j loop should be executed 1275 times. After, when j reaches 1275, it will come out of the inner loop. So which means that, so 1275 into times is the number which you give at the function call. Either it can be a 5000 or it can be 100. It can be anything, but it should be in microseconds. Okay. So that's what the delay function is. So here 1275 is a constant. By trial and error, I have given this number. So there is no specific reason for this. And coming to the main function, so here this is the main function where we usually write all the instructions which is related to operate the stepper motor. So in the main function, I'm defining one variable. So that is nothing but s, which is of the type integer type. So again, s is a looping control variable. So here I'm using for loop. Two for loops. One for loop is to rotate the motor head in clockwise direction. Another for loop is used to rotate the motor head in the anti-clockwise direction. So to control the for loop, I need one control variable. So that is nothing but as next. Next instruction is IODIR. IODIR 0. What is this IODIR 0? IODIR stands for input output direction. So what's the use of this? To set the direction of a pin. So you can set the direction either input or output. Okay. So 0. Here we have a 0. IODIR 0. 0 stands for port 0. Here all the four pins which are associated to the stepper motor are comes under port 0. So that's why I have written 0. IODIR 0 and or equals represents the output direction. Okay, na, or 0 is represents the output direction, and the value which I am passing is the register configuration which I am passing is 0x. 0x, as you people know, 0x stands for hexadecimal number, then 4 zeros F triple zero, which means that I am setting all the 4 pins to the output. I am setting all the four pins as the output direction, setting all the 4 pins starting from P012 to P015 to high, making them as the output pin. Okay now, so if we don't set the all the 4 pins as output pin, then obviously if you don't set this, then obviously that output will not be generated, which means that the motor will not be rotated. Okay, so first we need to set the direction. So here we need to set the direction as output direction. After that we need to clear the data. So we need to clear whatever the data which is present on that port pins, in all the 4 pins, that should be cleared. So to make the new transition or to make the new rotation, we need to clear the older data. So that's why IOCLR is used. IOCLR stands for input output clear. So basically it is used to set the pin to low state, and it will also clear all the data which is stored on that pins. Again, why 0 is used after IOCLR and tell again 0 stands for port 0. As we know, all the 4 pins are comes under port 0. So we are writing this instruction for port 0 for the microcontroller. And the register is equal to register configuration is 0x followed by 4 zeros F triple zero, which means that whatever the data which is stored in the all these 4 pins, that will be set to low, and all the data, all the older data will be cleared, and it will make all the 4 pins to rotate either in anti-clockwise or in clockwise freshly. So then we have a for loop. So I'm setting a for loop. I'm initializing s is equal to 0. S is a loop control variable. Then the s will iterates up to 60, which means that 60 times all the instruction which is defined inside the for loop will be executed, which means that the motor will rotate either in clockwise or in anti-clockwise, but it will rotate in 60 times. It will rotate 60 cycles. So clockwise rotation. So first for loop is all about the clockwise rotation. For each iteration, motor will rotate one cycle clockwise. Yeah. So then under for loop, so the first instruction is IO clear 0. So 0x followed by 4 zeros F triple zero, which means that I am clearing or I am setting all the 4 pins to low state. After that, after setting all the pins to low state, I am setting only one pin to high state. So what's that? I'm setting pure 0 12th pin to high state, which means that coil A is activated. And as I told, at a time you can activate only one coil or one pin. So which means that I'm activating only one pin. So IO set to 0 is equal to 0x followed by 4 zeros 1 triple zero. What I'm doing here, setting pure 0 12th pin to high state to rotate the motor in 90-degree. So as you people know, so the circularly all the 4 coils has been attached. All the 4 coils are attached. So here, if we activate one coil, obviously the motor will rotate up to 90-degree. So if you activate 2 coils, then obviously the motor will rotate. The head of the motor will rotate 180 degrees. So like that, if you activate all the 4 coils, then the motor will complete one cycle. So one cycle, if the motor wants to complete one cycle, then all the 4 pins should be activated at different times, not at the same time. So first time I'm activating the first pin, that is nothing but 4012 pin, which means that I'm activating coil A. After that, there is some delay. So after some delay, so next the second coil B should be activated. So then the clear function, the clear instruction is usually used to set the all pins to low state. After that, after setting all the pins to low state, then I'm setting the second coil to high state. That is nothing but 4013 pin to high state. Then the motor will rotate to 180-degree. And after some delay again, all the data will be cleared. After that, the coil C should be activated. So to activate coil C, the register configuration is 0x followed by 4 zeros 4 triple zero, which means that setting the port 0 14th pin to high state, and now the motor will rotate up to 270-degree. And after that, again some delay, again some I'm clearing whatever the pin which has been set to high state. So all those pins will be set to low state by IO clear. Then I'm setting the last fourth coil, the coil D. So that coil is setting. So to set that coil, so the register configuration is 0x followed by 408000, which means that setting 4015 pin to high state to rotate the motor to up to 360 degree. So like this. So if you execute all these instructions, now the motor shaft or the motor head will rotate one clock cycle. So like the next thing is, now s will be incremented, to 1. Then it will go with this next iteration. In that iteration, again the motor head will complete another cycle. So like this, when when s reaches a 60, the motor will rotate 60 times clockwise. Okay now, so if you activate coil A, then coil B, then coil C, then coil D, then the motor will rotate in clockwise direction. If you activate coil D, after that coil C, after that coil B, and after that coil A, then the motor head or the shaft will rotate in anti-clockwise direction or in reverse order. In the first set of operation, I'm rotating the motor head in clockwise, which means that first coil A will be activated, after that coil B, after that coil C, after that coil D. So like this, the rotation will be in clockwise. So in the next set of operation, same instruction, but I will rotate it in anti-clockwise direction or in reverse order, which means that first coil D is activated by IO set as triple 408000. After that, coil C should be activated. To activate coil C, 40400, and after that coil B should be activated. To activate coil B, 402000. After that, coil A will be activated. So the register configuration and the set to IO set is 401000. If you activate the coils, or if you activate the pins from port 015 to port 012, then the rotation will be in anti-clockwise direction. So again, in anti-clockwise direction, so there is a for loop. So where S is initialized to 0. In 0th iteration, the motor head will complete one cycle, then s will be incremented. Each and every time when s is incremented, the motor shaft or the motor head will rotate with one cycle. So when s reaches 60, which means that the motor head has rotated 60 times. After that, when h reaches 60, then it will come out of the for loop. Okay, so that's what so these are the instruction set which we are using in stepper motor. Hope you all have understood. It's very easy once go through this. So if you have any doubts, please do WhatsApp me. Okay, then so this is the program, actually very simple program, so it can easily understandable. After this, how to execute the stepper motor. So then after writing the program, save this program, then you need to compile and build the hex file. Okay, why you need to build the hex file only in part B and ಹೇಳಿದ್ರೆ, the microcontroller will accept the file only in terms of hex file. Hex file is an image file which is created after successful compilation without errors. So that X file should be dumped to the microcontroller to execute the stepper motor and to rotate that in clockwise as well as in anti-clockwise direction. So first you need to rebuild. Before rebuilding, we need to do some changes, or we need to do some settings. So what settings until so select this target one under project dialog box. Select this target one, right click, set options for target one. Then here you need to select output. So here you need to check this create hex file. Okay, there is an option called create hex file. You need to check this, which means that whenever you compile the program, at the compilation, usually the high level program will be converted into the machine level program. So when you convert the program from high level to machine level, so after successful compilation, one file need to be created. That file is called as hex file, which means that the why we need this hex file until again, the microcontroller will accept the file or the data only in terms of hex format. So that's why hex file need to be created. So just check on this and give the name of the hex file. So here the hex file should be what stepper motor. Okay, I will give the hex file name as a stepper motor. Don't give any extension here. And another option is there, that is called as linker. So under linker, we have an option called use memory layout from target dialog box. you need to check this. You need to check this and click on OK. So after doing these changes, now again save the program and rebuild the program. So this is a option which is available in Cleal Microvision 4 rebuild option. You need to rebuild the program. Now it will assemble the startup.s library file to our program. After that it will compile the program. So after that all the library files will be linked. After linking the library files and after successful compilation without errors, so then the hex file will be created. So after this, to dump the hex file to the microcontroller, we need another application. So just minimize this. So another application is a Flash Magic. Double click on this Flash Magic. So the Flash Magic application is used to dump the hex file to the microcontroller. So when you double click on the Flash Magic, so it will get open. So it will take some time. So yeah. So now it has been opened. So you need to select the device LPC2148, then COM port, COM2, then baud rate is 9600, interface is none ISP. So all these are predefined settings. No need to set these values each and every time when you execute the program. So one time these are one-time settings. Okay. Then here we have an X file. Go to browse here. Go to the root project folder which you have created at the desktop. So in this I have created the PROG. Double click on this. So here you can find the hex file steppermotor.hex. Select that steppermotor.hex. Click on open. So now the stepper motor hex dot hex has been selected. Now you need to click on this start. After start, here you can see the processing bar is that. So when you click on the start, it will take around 10 to 15 seconds to process the data. Or so at this time, the entire hex file will be dumped to the microcontroller. After processing, obviously your motor will rotates in first it will rotates in clockwise direction, because that's the first set of instruction which we have written in our program. After executing the motor in clockwise, then the motor head will rotate in anti-clockwise direction for 60 times. So the microcontroller using the Flash Magic software. So select this Flash Magic. So then go to browse. So here go to your root folder where you have saved the program. So select the lab programs folder, then select st.hex. So this is the hex file which we have created, so which has been created from the program. So select this st.hex. So then click on open. Okay. So after that you can click on this start button. So now we need to connect the stepper motor to the microcontroller. So as I told, so there are 4 pins here. So there are four pins in the microcontroller. So and there is a notch at the top. So here you need to connect the microcontroller. Over here you need to connect the stepper motor. So this is the stepper motor interface. So as you can see, so there are 4 pins. So I am connecting this stepper motor. So now you can see the motor head is rotating in clockwise as well as in anti-clockwise. This is the output.